In this lesson, we're going to look at a third form of a quadratic function called intercept form. So just to kind of review, we've already talked about standard form, which is y equals ax squared plus bx plus c. That was standard form. Then we talked about vertex form, which is y equals a times x minus h squared plus k. And now we're going to talk about intercept form. So in the box below, we have y equals a. In parentheses, we have x minus p times x minus q, with zeros at p and q. So a couple things. Intercept form, which it says right below, is kind of like factored form. So that's actually one of the things we will do in the next lesson is we will start with standard form and convert to intercept form by factoring. But you can see that you have two sets of parentheses, so it's factored. Also, when we're talking about intercept form, it's not y-intercept, it's x-intercept. So if you think of any parabola and it may cross the x-axis twice, those are called your x-intercepts or your zeros. So basically, we look at those x values, and in our equation, we have x minus p, which is one of those values, and x minus q, which is another one of those values. So when you're looking at a problem in intercept form, you can pretty easily find those those x-intercepts or those zeros. So that's what we're going to do in example 1. We're going to look at the function and we're going to write down the x-intercepts. In example 2, we're going to work backwards and we're given x-intercepts and then we will write the equation in intercept form. So for example 1a, if I want to find the x-intercepts here, think about any time you're finding a y-intercept, you plug in a 0 for x. So if I want to find an x-intercept, I would plug in a 0 for y. Now if I plug in a 0 for y, to solve for x, I'm basically using the zero product property. If x minus 3 times x plus 5 is 0, either x minus 3 is 0 or x plus 5 is 0. And here I'd get x equals positive 3. Here I'd get x equals negative 5. Now technically when you just have x equals a number, these are called the zeros. But if you write them as ordered pairs, 3, 0, negative 5, 0, this is what we call x-intercepts. And that's what the problem asks for. So from now on, I'll put all the answers as ordered pairs like this. But just so you see the difference between zeros and x-intercepts, it's just the way how you write it, whether you write it as an ordered pair or not. All right, in part B. This time, we have y equals negative 6 times x plus 1 times x minus 4. So once again, we're plugging in a 0 for the y. And when we use zero product property, negative 6 will never equal 0. So nothing really happens with that. We basically need to solve x plus 1 equals 0 and x minus 4 equals 0. So here x equals negative 1. And here x equals positive 4. So my x-intercepts are negative 1, 0. And 4, 0. And those are my answers to part B. Part C, I have a 4x equal to 0 and an x minus 3 equal to 0. Here I get x equals 0, and here I get x equals 3. So to write those out as ordered pairs, I have an x-intercept at 0, 0, and another one at 3, 0. And we can just do this last one together. Notice here I have an x plus 2, and I have another x plus 2. So when I solve, I get x equals negative 2, and I get x equals negative 2 again. So this basically means you just have 1, 0. It's repeated. You don't have to write it out twice. You can just say your x-intercept is negative 2, 0. But what this would look like on a graph is something like this, where we're only crossing the x-axis once, and then we can see that this graph is opening upwards. So our parabola would look something like that. Where on the rest of them, like I drew above, you can see your parabola is crossing over the x-axis twice. Okay. Now it is possible, there's a third situation here where you have a parabola where the vertex is above the x-axis and it opens up and it doesn't touch the x-axis at all. So every single parabola either has 0, 1, or 2 x-intercepts. Now most of these problems we will give you do have 2, but it is possible to have only one like part D or to have 0. All right, example 2. We are working backwards. We're given two x-intercepts or zeros, and we want to write the equation in intercept form. So this is like P and Q, and now we want to write out y equals x minus P and x minus Q. And it doesn't say, but since we have no other information, I should have added this to the directions. We're just going to be using an a of 1. Okay, otherwise if we had an equation in a different form, we'd be able to see what the a value is by looking at the other form. But all we have here are the x-intercepts, so we'll just use an a value of 1. All right, in part B, I have y equals x minus negative 3, so it becomes x plus 3, and then x minus 7. So notice if you look up above, like every set of parentheses, x minus 3, our answer was a positive 3. It's always the opposite because back in our original form, we have a minus in front of the p and minus in front of the q. So when you see a negative 3, you have an x plus 3. Positive 7, you have an x minus 7. There's the equation in intercept form. All right, here was 0, 0, and 2, 0. I have y equals x minus 0 and x minus 2. I would simplify this and just change x minus 0 to just x. So we have y equals x times x minus 2. And for the very last one, y equals x plus 5 times x plus 1. So the two goals in this lesson were to start with the function in intercept form and find the x-intercepts. And then in example 2, given the x-intercepts, write the equation in intercept form.